Hi everyone, welcome to today's session. Today we're going to have a discussion on the maths behind the self-attention mechanism of transformers. As we are all familiar with transformers, transformers is the brain behind every large language model. Either it's a ChatGPT, either it's a Mistral, either it's a Gemini, or it's a DeepSeek, or any large language model. Transformer is the um, brain behind every large language model. And the self-attention mechanism is a core component of the transformers that allow it to pay attention to the input prompt and generate the output according to the user requirement. So today we are going to have in-depth understanding and the mathematical understanding of the self-attention mechanism, how the self-attention mechanism is computed, and we're going to get into the detail and we're going to see how the weights and QD values are computed using the self-attention method. So myself is Ehtisham Raza. I'm working as a AI strategy lead at Vision Technologies. I'm working at Data TechCon as well as a AI engineer and educator at LUMS. I'm also working at LUMS. I'm working as a teaching assistant at LUMS. So if you guys are interested to connect with me, you can easily connect with me over the LinkedIn. If you guys have any query, if you guys have any question, if you can need any kind of guidance, I'm always available on my LinkedIn. You can easily connect with me and you can ask regarding your query. So without any delay, let's start our session. First, we'll have the introduction of the self-attention mechanism. Before we proceed, let me give you a little in context about the self-attention mechanism. When we enter any prompt to the chat GPT or any large language model, either we are using Gemini, we are using DeepSeek, or any open source large language model, we enter the input in the form of prompt. Let's say I'm asking my large language model, I'm asking a chat GPT, can you please write an email? In the email I have to write I have to write an email to my boss wherein I have to request him a leave for next 3 days. The reason of the leave, I'm not feeling well, so I need a rest for next 3 days. So that's why I'm applying for. So my context is I'm applying a leave for sick leave. I'm not feeling well. So this is my context. So self-attention mechanism is a type of mechanism that allow your large language model to pay attention what is the context of the input prompt. In my input prompt, here in this example, I'm requesting my boss to give a leave for next 3 days. So this is my context. So my all the email should be catered around this context. Let's say I should be requesting my boss to grant a leave for next 3 days and give me any facility and should be a paid leave and XYZ, whatever that is. So this is how the self-attention mechanism works. We are human, we have the cognition, we understand, we behave according to our senses, but machines are programmed. How we can get the right output, what we are trying to get from them, this is the real part. So in this large language model, the self-attention mechanism is a key component of a transformer model. It is one of the key component of the transformer model that allow the each input token to attend every other token in the sequence. What is meant by this? You have entered a very big prompt. You have explained everything to the chat GPT. I'm requesting you please write an email for my boss so I can request him. I can get a sick leave for next 3 days. So in my this email, my tone should be very light. I should be requesting. So this is my input prompt. And my prompt should be like that. So chat GPT can come up with the right output which I can use to send to my boss. So this is my input token. So self-attention mechanism allows you to pay attention to your every single input token, and after understanding it should create the dependencies. The output generated should be very well informed and should be very well structured. So self-attention mechanism is a core component of the transformers model. It is available in every single large language model. If we talk about ChatGPT, if we talk about Gemini, it is always available. You can have multiple type of attention model, attention mechanism, but attention mechanism always going to be there. Contextual understanding. In this example, my context is I am trying to request a leave for next 3 days because I'm not feeling well. So this is my context. So this self-attention mechanism enable the large language model to understand the context and the relationship between the input in the input token with other tokens. So my I should be very polite. I should be requesting, and that should be giving me the output which I can use for to further email my boss. Scalability, self-attention mechanisms. The main advantage of the self-attention mechanism, you enter a very big prompt. And in a very few seconds, ChatGPT come up with your solution, come up with your desired output. That is because of the parallel processing. Before this, we had the recurrent neural network, long short-term memory algorithm neural network that used to process your input text in a sequential manner. It means when your once first prompt is processed, then it used to go to the next, then third, then fourth, then sixth, then like that. But self-attention mechanism allow the parallel processing, mean multiple prompts, multiple input tokens can be processed. Versatilities used in a wide range of NLP tasks such as translation. Yes, you have the input prompt you want to convert into one language to another, you can use it. Summarization. Yes, if you want to summarize a very big text into a small few lines, you can use it. You can understand the context. Obviously, when you do summary, you keep the context, you keep the crux of your input text and just simply summarize your whole text. So this is how the summarization. So it can do the summarization task very well, and obviously text generation, just like an example of email. I have to write an email. So this is a text generation task. So it can do very well. Core concept: each token compute a set of attention score. Attention score is calculated for each set of input prompt with all other tokens determining the level of influence each token has on the output representation. So it identifies the significance, the level of influence of each token with the output here. So this is the little introduction about the self-attention mechanism. I'm pretty sure you guys are familiar with the transformer architecture. This is a very famous architecture, was out in the 2018 from the Google. So this transformer architecture has the two main components. First is the encoder part, and second is the decoder part. So encoder part is responsible for taking the input. Input goes in the form of embeddings, as we are already familiar with large language model or your any machine don't accept the text string characters as an input because they are machines. Machine can't understand the textual input. They only understand the numbers. They understand the value 0 and 1. So must have to convert this input into the embeddings. That embeddings are just a representation of the text into the numbers, and then we apply the positional encoding. When we convert the input text into the embeddings, there's a problem. Maybe after converting from textual to input conversion, maybe the context of your input would be changed. So to make sure your context is not changed, we apply the positional encoding. So positional encoding makes sure the input text will have the same context, just like it was in the form of textual representation. Then we have a multi-head attention. Our transfer architecture can have to any number of attention layers. It can be 10, it can be 20, depending upon the architecture of the transformer. And then we have the normalization layer. Then we have the feed forward layer. Then further it goes like that. So after doing all this thing, then it goes to the next for the decoder layer. Encoder layer is just simply use the input and just simply encode this input to further proceed. And in the decoder layer, we have the layer which is basically used to generate the output. So output is being produced. Let's say you have asked the chat GPT to generate an email for me. So by the way, chat GPT is a use only the decoder architecture. It doesn't use the encoder. So in the encoder, it starts generating the output for you. So just like we have a translation task, on the one side, encoder will encode all the input text, and on the decoder side, it will start generating the output for you. So this is just a recap of the architecture of the transform architecture. Those who are not familiar, so they can also get the understanding. In the encoder, we have the two main components. First sub layer has the feed forward layer. Feed forward layer is all where all the normalization, all the things are up there, all the processing are applied, and further we have the normalization layer. Obviously, the normalization is applied on that. Then on the second sub layer, we have the attention layer. So in the attention layer, it can be n number of attention layers that is being used to apply on your input prompts. So the more the attention layers you have, the more precise, the more get better accuracy, the more better understanding of the transformers architecture you will have of your the better understanding of your transformer will get from the input text. Then we'll have the normalization layer. Normalization just applied, so it can get the input should be normalized, so it should be getting the same as it is expecting. So this is the encoder layer. Attention layer, in the attention layer, as we get the out input from the embeddings in the form of embeddings, then it apply the positional encoding, then it simply pass to the attention. So attention layer just simply calculate the weights on which part of the input text I have to pay attention, and it just simply make sure I'm paying attention to the right input context. So let's say my user is asking to generate an email for 3 days. I'm not feeling well. So it means that user is not feeling well. He has to apply for a sick leave. He's not asking for a casual. He's not asking for any short leave. He's not asking for anything else. So this is the multi-head attention, where the attention is applied on the input text. So attention layer will be responsible to getting the output, getting the context from the input. Self-attention is a mechanism that allows the transformer models to focus on different parts of the input sequence when constructing representations of each input element of sequence. So it is a mechanism which is available in every transformer-based architecture that focus on different parts of the sequence. Yes, it focus parallelly for different parts of the sequence and try to understand the context, what my user is trying to explain, what my user is requiring from me. So self-attention makes sure the the user requirement should be fulfilled, what my user is trying to achieve should be considered. Let's take an example. This is an example. The cat sat on a mat. Just a one line text, one line sentence. And we are going to create a matrix. We're going to visualize this and going to calculate, going to see how the attention mechanism pay attention to every single word. So we have the where we have to pay the focus, the cat sat on the mat, on the columns and on the rows wise as well. So we are going to say, let's say if I pick a sat, sat is correlated to is in which with which word the sad has the correlation. So if I pick the sad word, it has the high correlation with the cat. Obviously, cat sat somewhere. Okay. Now this is making sense, but if I have another word, if I have to pick another word where this cat is sitting, where it is sitting. If you see the next highest correlated word is the mat. So cat, sat, mat. So it is making a little understanding, okay, the cat is sitting on the mat. So this is how the each input word, each input sentence is translated into the correlation matrix, and the correlation matrix computes the correlation of each word in the text. So cat, sat, mat has the highest correlation with each other. So in my input in this prompt, I am getting, okay, so I'm having a discussion related to the cat. So the cat is sitting somewhere. Okay. On where it is sitting on a mat. So this representation makes understanding the of your self-attention, makes your self-attention mechanism to understand very well about the context. So the context is understandable here. So now it is understanding the cat is sitting on the mat. Key components of your self-attention layer. So there are three main components. First is the input embeddings, then is queries, key values, and the weighted matrices. So there are three main components on which all the mathematical calculations, all the mathematical weights and stores are applied, and where the computations are being applied and it calculates that. So input embeddings, let's go ahead. Input embeddings are nothing just like a representation of textual representation of a representation of text into the numbers. Because we are already familiar, we have learned this since our childhood. Computers don't understand the language of humans; they understand the language of zero and one. So to make sure computer is understanding, the machines are understanding what we are trying to explain them, we have to convert from textual representation to the numerical representation. So first in the embedding input sentence, in the input sequence, we applied a tokenization. What is meant by tokenization? You are converting each word, you are converting splitting the whole sentence into a single unique, single word. So I love singing is going to be I separate word, love separate word, and singing separate word. And if you see the input embeddings of this whole sentence, it will be a specific representation of numbers. So 0.5 is for the I, love 0.8, and singing is 1.2. So this is how the input embeddings are being made. So input is converted into the embedding because every machine learning or any deep learning or any large language model only understand the numerical represent input as a numerical representation. So to make sure, and obviously inside in the large language model, they have the computation. They apply different type of numerical different computation. They apply different type of dot products. They different type of normalization. They do different type of differential equations. So this is only applicable, these things are only applicable on the numbers, not on the text. So it is compulsory to convert your input text into the representation of padding in the form of numbers, so it can be further processed by your large language model. Key component of self-attention layer. So there are three main components, key components we are already talking about. First was the embedding. Then we have the query keys and values. So what is queries, keys and values? Query basically represent the part of input you are focusing on trends. Okay, let's understand this. As let's read it again. Represents the part of the input sentence. Okay, it's representing the part of input sentence where you're focusing. Okay, let's take an example. Question you have in the project. What are the latest market? I'm trying to explain what are the latest market trends. I'm trying to answer this question. So this is my query. Let's say just similarly in my case, I am asking in the example which I gave you earlier. I have to write an email to my boss where I have to ask him where I have to request him can grant a leave for 3 days so I can rest. So this is my question. This is my query which I have given to my learning model. So what are the latest market trends? So this is my query. This is just an example. And key basically represents the information available in each part of the input sentence. Okay. Let's say, what are the latest market trends? Okay. This is I'm trying to understand. Obviously, to understand the latest market trends, I must have to take certain steps. I have the data set of the market. I have to get the insights of the market trends. What are the steps I have to take to get the market trends? First, if I have the data, first member will go and clean the data set. Then I can further proceed to get the market trends. Second member will visualize that clean data set. So the clean data set is available. Now it's time to start visualizing. So after getting the visualizing in the form of charts, I can get some. And third member will be analyzer. So this is my key. What is the available inside the input sentence? This is going to be the key. Third is the value, represents the actual information content from each part of the input sequence. So this is what we are going to be the output. This is the end product. Member one will be process the output data. Yes, process the output data. Member two will be visualizing the charts. He will be creating the charts and different type of graphs so I can get the market trends. And the member three will be the data and will be performing the data analysis report so we can better. So this is how the queries, keys, values are the components. They basically first represents the input sentence where you're trying to focus. Second represents the available part in each input sequence, and third represents the actual information what you're trying to get from that. Third part is the weighted matrices. So weighted matrices basically help us to understand find us the computations of the query, keys, and values vectors. So let's understand this. So just these are just weighted matrices that allows you to find the vectors. Obviously, vectors are which is passed to the for the attention layer. So that allows you to get the computation that allows you to get the matrices, which you can just simply pass to the further attention layer. Let's take an example and then let's jump into the mathematical calculation. I'm going to keep it not a very detailed, not very complicated. I'm going to make it simple. So anyone with from any background, those who are learning about the transformers, about the large language model, about the self-attention mechanism, they can grasp this topic very well. So they can have the understanding of this as very well. Example, we have a hello world input. How the embeddings of this word is going to look like, as you know, the when you get any input text, you get into the embeddings. So embeddings are applied on this one. Let's say x1 is the hello world, word 1 is the hello, and embedding of this word is 1 0. W2 is the world, and the embedding of this is x2. Then we have the positional encoding implemented on this, and then we have a query. We're going to make a query of this one. So to get the query, we're going to have a query q1 x1 dot product with w. W is the weighted matrices which we have already defined, and x1 is the above input embeddings which we are going to define. Same q2 x2 dot w. X2 is the above embedding which we have from the above input text, and w is just a weighted matrices. So x1 dot product with w, x2 dot product with w. This is going to be the q1. Q1 is 1 1 after applying the dot product, and q2 is the 0 1. So this is just a query calculation form for this is how the input is going to be this. So first it converts the input into the embeddings, then after this the input embeddings is going to multiply with the weighted matrices for the query, and then it will generate a q1 and q2, whatever the number of words, whatever the number of inputs you have. So it's going to be n number of queues and number of queries for your use case. So just like I took an example of where we have only two words. Further, the query is calculated, then we'll have the keys. Keys are just same like that. We have the x1 dot product with weighted matrices, x2 dot product with weighted matrices. So x1 we already have calculated above in the input embeddings. Then we have the weighted matrices 1 0 1 1. So it's going to be the dot product this one with this matrices, 0 1 dot product with this matrices. And in the last we'll have the k1 1 0, and in the k2 we have the 1 1. So this is how the keys are being calculated. So first it will calculate the queries, then it will calculate the keys, and in the last it will calculate the values. So values as the last it generated will explain the output representation which we are trying to achieve. Then V1 is going to be again x1 dot product with W, the weighted matrices. V2 x2 dot product x2 dot product with W, the weighted matrices. 1 O dot product with this weighted matrices, O1 dot product with this weighted matrices. So then we have the V1, then it will at the end, it will have a O1, V2, 1O. So this is going to be the our V1 and V2. So first we had the query, then we had the key, then we had the value. Now further, how it's going to calculate, we got the matrices, we got the query keys and values. How it's going to proceed to get the attention scores, we got the attention score. So now we have the Q1, K1, Q2, Q1 dot product with K2, Q1 dot product with K2, Q2 dot product with K2. So it's going to be up, the dot product is going to be applied here. So Q1 dot product with K1, Q2 dot product with K2, Q1 dot product with K2, and Q2 dot product with K2. So all the dot products will be applied here, and the score of the hello will be calculated. So the output of this one is 1, output of this is 2, output of this calculation is 0, output of this calculation is 1. So in the last we're going to have the score of the hello. So attention score of this hello is 1 comma 2, and the attention of the score of the world is 0 comma 1. So this is how the attention scores are being calculated by applying the dot products. They create the first the query vectors. The query vectors are calculated, then it go for the key vectors, then key vectors are calculated, then in the last it go for the values vector. So in the last, they come up with attention scores. That attention score is further processed by the further feed forward layer, then it further path also. So this is how the attention scores are calculated using the mathematical computations. Why do we need self-attention in our large language model? Obviously, we enter a this is the example I gave you is very short, but this is not all the time you're going to use the very short examples. When you are using the chat GPT, you enter a very big long range dependencies. Sometimes you either, if you're working in a programming task, you just simply capture copy your whole code and paste into the chat GPT and ask the chat GPT, can you come up with a solution? What's wrong with this output? What's wrong? I'm not getting this output. So there are many uh, cases where you use this And why do we need this? To understand the long range dependencies. So to understand, you copied the whole code and you just simply ask the chat GPT, please fix this code. You have not explained the chat GPT what's going on. It's that you just simply relied on him. Please fix this code. So chat GPT has the attention mechanism that can understand a long range of dependency, that can pay attention to every single line of code. And after understanding the every single line of code, it can come up with a solution that you can utilize. Parallelization of for efficiency, yes, the previous neural networks were working in a sequential manner. They used to work in a sequence. They were not working in a parallelization. These large language models do have the capability. They can go with the parallelization. They can process the multiple attention layers at the same time. They can go with the multi-head layers attention easily. Context aware representation, just like we had an example, we were trying to generate an email from our boss where we need a leave for 3 days. So this was our context. We are sick and we are applying for a leave for 3 days. So the context is I'm applying for a leave, a sick leave for 3 days. So my context is this one. So my tone and my all the my textual explanation should be in a very lighter way. So my boss should understand I'm not doing very well. I'm not feeling very well. So he or she should grant me a leave for next 3 days. So this is called context aware. So this large language model is backed by the transformer architecture, and this transformer architecture have the self-attention mechanism that make is context aware representation. Improved accuracy, yes, accuracy is improved, and flexibility, flexibility is also improved by getting more contextual awareness. It is generating the more context aware output for your responses for you. Handle variable length sequences, yes, there was a limitation in neural networks. You cannot pass up to certain number of length, but in large language model, but in transformers based architecture, you can pass up to certain number of tokens in your input, and that input can be easily processed in a parallelization, and that can give you a very high and very accurate responses. So that's it for today. We have seen what is self-attention. We have seen how the self-attention scores are being calculated behind the large language model inside your inside your transformers architecture, and how they further process and how they further proceed with your parallelization, and how they and get the in context-based solutions for your problem. So that's it for today. If you guys have any question, any query, do comment, and I would love to answer your questions in the comment section. So if you have any question, please make sure you can make a comment. So I would love to answer your question. Thank you.